Hello everyone, I welcome you all to my channel. Here we'll be discussing mostly about the basics about computer science, especially about database management system. So to give it an intro about me, myself, Dr. J. Jislan, I'm working as the Associate Professor in the Department of Computer Science and Engineering, RMK College of Engineering and Technology. With a strong passion for teaching and academic excellence, I specialize in core computer science subjects such as Dbms, programming, software engineering, blockchain technologies, etc. Over the years, I've been dedicated to empower students through concept-driven learning, outcome-based education, and real-time industry-oriented insights. This channel serves as a platform where I aim to make technical concepts simple, accessible, and engaging, whether you prepare for your exams or you prepare for your interviews. Join me in this new learning journey. Let us explore the depth and beauty of computer science one concept at a time. So very first thing about this lecture, we'll be seeing about the data models. We'll explore and deep dive inside the data models. Now you might be wondering, what exactly is a data model and why it is so important? Think of a data model as a blueprint for building. Just like a blueprint shows how different parts of a building connect and interact, a data model defines how data is structured, stored, and related within a database system. Whether you are designing a student database, an inventory database, or a banking database, choosing the right model determines the efficiency, scalability, and reliability of your system. By the end of this session, you'll be having a clear understanding of the different data models, their characteristics, their advantage, and where the all they can be applied. So before moving inside these data models, we'll see a little bit basic concept about what is a data, what is a database, what is Dbms, and then we'll go inside what is meant by a data model. So what is a data? A data, as you all know, it's a collection of raw facts and figures. Similar to a raw material, it can be processed by any machine in order to be got as an information. If you have a look at this picture, the letters, the alphabets, the numbers are jumbled together. That forms the raw data actually. This data, it is clubbed up together in some meaningful form that creates information. Out of the information, we gain the knowledge through study or experience. This information only helps the human beings in decision making. Not only the human beings, of course, it is used in your advanced data analytics. From data, we go to the information. From the information, next we go into the intelligence part. The next thing which we see as the introduction is a database. As you all know, data is a something logical, some raw facts you call it as a data. This collection of logically related data and similar data, you call it as a database. To put it in other terms, an organized collection of related information so that it can be easily managed and updated. Examples we have the dictionary, airline database, student database, library, railway timetable, and YouTube. These are some of the examples of the database where related informations or similar data are clubbed up together and they are stored as a whole. Moving on to the next thing, what is the definition about our own subject? Database management system, synonymously called as a database system. So as we all know, a database system, it's a collection of interrelated data. That's nothing but a database, a set of programs or a software that allows users to access the data and modify these data. Modify in the sense you can create, you can alter, you can delete, you can perform all the database operations. A database management system, it's an integrated set of programs that is used to create and maintain the database, right from creation till the maintenance of the database and the durability of the database. Everything comes inside a single package known as your database management system. Or else you can put it in other terms also. It's like an intermediary layer that acts between the underlying hardware or the database and any end user. For a user to communicate with the underlying database, they'll be using the Dbms software. And these are some of the top 5 database softwares available, which is known to you: Oracle, PostgreSQL, Microsoft SQL Server, MySQL, and IBM DB2. Next, moving on to the core things of data models. What is meant by this data modeling? As I already told you, Just you're going to construct a house, right? You have to see the prototype or the model. That's called as a blueprint. Similarly, you want to construct the actual database. You want to know how the data is there, how to structure it. Okay, so that's nothing but a collection of data, the relationship and the constraint as in the pictorial form or some kind of representation. That's called as the data model. So we can classify or categorize the data model into conceptual data model, representational data model, and physical data model. Moving on to the first thing about your conceptual data model. It's nothing about it's otherwise called as a high level data model. See, an end user is there. Imagine a simple library management system itself. You want to create a library database. Who can be the end users? It can be a librarian to manage the database, or it can be any student or faculty to access the books. Each and every one will perceive the database in their own view. For a student, the student is bothered about how many books he has lended already, what is the new books he can get from the library. The librarian is bothered about how much stock he is having, who all have lended the books and what are the fines and all those things. So having different views of the data. So the high level or the conceptual data model provides concepts that are close to the way many users perceive the data. Conceptually, how users can see the data, that's called as your conceptual data model. The last data model, that's a lower level of your data model, you call it as a physical data model. That's nothing but how the actually the data is stored in the database, right? In the magnetic disk, in the hard disk, how the data is stored, what kind of indexing mechanism is used, how can I retrieve the data, all those information can be given in the physical data model. That's the lowest level. So we need an intermediary model to model exactly for the DBMS system, right? That's called as your representational data model. They provide a way to represent a data in a way such that it's understandable to users but also close enough to the way data is stored to be implemented efficiently. It should be both the way, it has to satisfy. The user also should understand in the terms of views, high level conceptual data model. Similarly, they are it is bothered about how the data is actually stored. To put it in simpler terms, what data structure is used in order to store the data. They hide some of the low level storage details, but still it can be directly implemented on a computer system. Low level storage details like exactly in which disk it is present, what kind of paging mechanism, retrieval mechanism is used. This is a wide classification of the various categories of data models. First, we'll see in detail about the conceptual data model. It uses concepts such as entities, attributes, and relationship. See, imagine you want to design a database. You get the requirements from the customer, right? You as a database developer, in order to understand the concepts properly, you'll be using the conceptual data model, that is otherwise called as an entity relationship data model. Here you'll be identifying what are the entities or what are the real-time objects that is used in a database and how they are related with each other or how they interact with each other. So this is the very first data model that is generally used for a developer or a database administrator to understand the concepts behind the actual database. So this model, actually it's a pictorial model in terms of entities. So these are called as the entity, and how the entities are related, it is represented in the diamond shape box. The properties about the entity are called as attributes, and it is given in the oval shape box. So this entity relationship model is the very first model of your conceptual data model. Okay, next moving on to the representational data model. It's nothing but how the data is represented, the intermediary data model, what type of data is used, what is the data structure that is used, right from your conceptual data model. The next level of your data model which we use generally is your the data model the system understands is called as a representational, otherwise we call it as an implementational data model. So these include the widely used relational data model as well as the legacy data models like network and hierarchical model is used in order to establish the relationship among the relational data model. Representational data model represents data by using the record structures. Example, you have your relational data model, network data model, and hierarchical data model. They come under the representational data model. Or as we all know, the relational data model, it consists of rows and columns. The data itself, database itself is represented in the form of a table. The rows are considered as record. That's why it's a record-based data model, right? Similarly, we have the network data model. So in order to represent the relationship among the tabular or the record-based data model, we'll be using the network data model. So the relationship such as one-to-one, one-to-many, many-to-one, and many-to-many among the databases can be represented in the form of network data model. Similarly, next we have the hierarchical data model. This type of data model, it's mainly used in scenarios where you give roles and privileges and in order to connect among the various databases. So a hierarchical data model is a data model in which the data is organized in the form of tree structure with one-to-one or one-to-many relationship. See, in a class, we have the student with some set of privileges. Similarly, the faculty or the instructor will be having some set of privileges. Both of them belong to the class. That's a uniform database. Here, the student can view in some attributes, but whereas the instructor can view the other attribute. That's the thing about your hierarchical database. Next, moving on to the physical data model. It describes how the data is stored as files in the computer, representing the information such as record formats, record ordering, and access file. To put it in very simpler terms, imagine a physical database is nothing but physical data model. It's nothing but how exactly the data is put in the magnetic disk or in the hard disk. What are the access mechanisms? How it will be used? Like indexing is a pure example for your physical data model. So in this presentation, we saw an overview about a data model and what kind of data model can be used for the various applications. Thank you. Meet you in the next presentation.